Welcome to The Explainer. So, we all know that the global solar industry is absolutely exploding right now, right? But here's a massive reality check. As solar rapidly scales up to literally save the planet, its own environmental footprint is being put under a microscope. Today, we aren't just looking at sunshine and sails. We are mapping out the incredibly strict standards that measure solar's true sustainability. Because, as solar energy scales up to power our world, the way we manufacture, deploy, and eventually recycle these technologies matters more than it ever has before. Okay, let's dive into this. Here is our roadmap for today. 1. The three solar markets. 2. Manufacturing and supply chain. 3. Ecological project impacts. 4. Grid integration. And 5. End-of-life management. All right, Section 1, the three solar markets. Let's look at global demand and scale. Now, this industry is defined by really intense global competition across three very distinct stages. To really grasp the sheer scale of this global demand, I want you to picture a split screen in your mind divided into three different scenes. On the far left, you've got a classic single-family home with sleek panels on the roof. That's the residential market. Right in the middle, imagine a massive industrial warehouse, and its sprawling, flat roof is just completely covered in solar technology. That represents our non-residential or commercial and industrial market. And then on the far right, picture a giant, sweeping solar farm stretching across an entire valley, hooked directly into the electrical grid. That is the utility scale market. These three target markets are exactly where this intense global demand for solar energy is actually met, and companies must fiercely compete across every single one of them if they want to survive. But that brings us to a really fascinating question, doesn't it? How do we actually measure the true sustainability of an industry that is already fundamentally known as green? Well, here's the turn. Massive global scale inevitably brings a massive environmental footprint. When you are out there manufacturing millions of panels and developing thousands of acres of land, you need strict, quantifiable accountability. And the solution for that is elegantly illustrated by the SASB standards for solar technology and project developers. Now managed by the IFRS Foundation, these basically serve as the ultimate industry benchmark. They are exactly what investors and companies use to track and report on absolutely everything. We're talking everything from the amount of water used in factories to the management of hazardous waste, all across those three target markets we just visualized. Moving right along to Section 2, manufacturing and supply chain. This is where the physical life cycle actually begins. Now, what's really interesting here is the sheer volume of raw data companies are expected to track. We aren't talking about casual estimates. Energy is literally measured in gigajoule and water in thousands of cubic meters. In fact, manufacturing solar photovoltaics is incredibly thirsty work. Certain processes require vast amounts of ultra-pure water. Tracking this accurately is vital, especially if these multi-million-dollar manufacturing facilities happen to be located in regions experiencing high water stress. And this actually builds into a super fascinating paradox. Manufacturing solar panels is, ironically, an incredibly energy-intensive process. Under the standards, companies must transparently report exactly how much of their manufacturing power comes from traditional fossil fuel-heavy grid electricity versus how much actually comes from renewable energy. Diversifying their own energy sources isn't just about, looking green. It actively protects these manufacturers from volatile energy costs and shifting regulatory uncertainties. Beyond just water and power, there is the highly complex supply chain of critical materials. We are talking about key inputs like polysilicon, gallium, and various rare earth elements. These materials are absolutely essential, but they carry distinct risks, from physical limits on global availability to rapidly shifting geopolitical trade policies. Properly managing the environmental risks and ensuring the transparent sourcing of these critical materials is absolutely vital for a solar company's long-term global competitiveness. All right, stepping out of the factory and into the field. Section 3, ecological impacts of projects. Building solar farms. Because building a massive solar project isn't just about, finding a huge stretch of empty land and setting up panels. Actually, scratch that. It's way more complicated than just finding empty space. It is a highly rigorous step-by-step process. First, developers must evaluate land rights and carefully assess ecologically sensitive areas. They have to avoid or mitigate impacts on endangered species habitats. Next, they have to navigate some incredibly complex environmental permits. And finally, they have to address community impacts. And that's everything from visual aesthetics and property values to construction noise and impacts on local water resources. So what happens if a company fails at those steps? Well, they face severe consequences. SASB actually requires companies to track the exact number and the total duration in days of any project delays or site shutdowns caused by ecological impacts or regulatory enforcement. Think about it. If you don't engage the community and protect the local habitat, your project stalls, costs skyrocket, and expected revenues simply vanish. It's a very direct financial consequence of poor ecological management.
Which brings us to Section 4, Grid Integration, successfully plugging into the grid.
So the crucial point here is that generating the solar power is really only half the battle. Delivering it is the other. Major integration barriers stand in the way. We're looking at limited connectivity to high-capacity transmission networks, the operational risk of curtailment, which is where energy is essentially wasted because the grid just can't handle the variable nature of solar, and a whole maze of complex energy policies. From net metering rules to fluctuating tax credits, shifting government policies, and outdated grid infrastructure remain huge hurdles to widespread solar adoption. Companies literally have to innovate constantly, maybe by adding smart grid tech or storage, just to make integration viable. And finally, decades down the road, we hit Section 5, End-of-Life Management, Panel Degradation. This is a massive, massive impending challenge for the industry. Do these panels just become discarded waste, taking up space in landfills, or do we prioritize high-value recycling and material recovery? Here's why this matters so much right now. Recycling isn't just an environmental win, it is a highly critical supply chain strategy. By recovering valuable materials from old panels, companies can reuse them in new manufacturing processes. That drastically lowers their long-term costs and reduces their reliance on those risky critical material supply chains we discussed earlier. To really anchor that point, let's look at this specific metric, 80%. The SASB standards don't just ask companies if they vaguely recycle, they demand specifics. They define high-value recycling explicitly as the recovery of at least 80% of the glass and 80% of the metals from end-of-life products. It sets a very high, very clear bar for what actually counts as sustainable material recovery. But it's not just about recovering the valuable glass and metal. It's also about managing the really dangerous stuff. Certain solar technologies, particularly thin film panels, can contain highly hazardous materials, substances like cadmium and arsenic compounds. Proper end-of-life management, including safe handling and disposal, is legally and environmentally essential. If companies mismanage this hazardous waste, they face massive regulatory penalties and severe reputational damage.
Which leaves us with this final, really provocative thought. As the entire world rapidly electrifies, will the solar industry actually be able to recycle its own success? We've seen today that operating in this highly competitive global market requires so much more than just selling panels. The long-term advantage definitely belongs to those who master both incredible technological scale and absolute holistic sustainability, from the water used on the factory floor to the community impacts out in the field, all the way to the recycling plant. Thanks so much for joining me on this explainer. I really hope this deep dive gives you a completely new lens to view the future of solar energy. Keep questioning, keep learning, and I'll catch you next time.